The human brain is a complex and mysterious organ. It is the seat of our consciousness, the source of our creativity, and the engine of our intellect. Despite centuries of study, we are only beginning to scratch the surface of understanding how it works. It is the command center of our thoughts, emotions, and actions. Every movement we make, every word we speak, and every emotion we feel originates in the brain. It is a marvel of biological engineering, with billions of neurons and trillions of connections. Scientists have been working for centuries to unlock its secrets. From the early anatomists who first mapped the brain's structure to the modern neuroscientists who use advanced imaging techniques to study its function, the quest to understand the brain has been a long and challenging journey. Now, a new tool is revolutionizing neuroscience, artificial intelligence, or AI. This cutting-edge technology is providing researchers with unprecedented insights into the brain's workings. By analyzing vast amounts of data, AI is helping us to map the brain in ways that were previously unimaginable. AI is helping us to map the brain, understand its activity, and diagnose disorders like never before. It is enabling us to identify patterns and connections that were hidden from view, offering new hope for the treatment of neurological conditions such as Alzheimer's, Parkinson's, and epilepsy. AI is a branch of computer science that deals with creating intelligent agents. These agents are designed to perform tasks that typically require human intelligence, such as learning, problem-solving, and decision-making. In the context of neuroscience, AI is being used to develop models that can simulate brain activity and predict how the brain will respond to different stimuli. These agents are computer systems that can perform tasks that typically require human intelligence, such as learning, problem-solving, and decision-making. They can analyze complex data sets, recognize patterns, and make predictions with a level of accuracy that surpasses human capabilities. This makes them invaluable tools in the field of neuroscience. In neuroscience, AI is being used to analyze vast amounts of data from brain scans and other sources. This data includes everything from electrical activity in the brain to the chemical signals that neurons use to communicate. By processing this data, AI can help us to identify the underlying mechanisms of brain function and dysfunction. This data is helping us to understand the complex patterns of brain activity that underlie our thoughts, emotions, and behaviors. It is revealing the intricate networks of neurons that work together to produce our conscious experience. With AI, we are on the brink of a new era in brain science, one that promises to unlock the deepest mysteries of the human mind. Imagine trying to understand a conversation in a language you don't speak. You'd probably feel lost, trying to pick up on any familiar words or gestures to make sense of what's being said. This is similar to the challenge scientists face when they study the brain. That's what it's like for scientists studying the brain. They are trying to decode a complex system of communication that is not immediately understandable. The brain communicates through a complex system of electrical and chemical signals. These signals are like the brain's own language, a language that is intricate and constantly evolving. These signals are constantly changing, making them difficult to decipher. Just like the weather, they are in a state of perpetual flux, influenced by countless variables. AI is helping us to translate the brain's language. Advanced algorithms can sift through vast amounts of data, identifying patterns and making connections that would be impossible for humans to spot on their own. AI algorithms can analyze brain activity data and identify patterns that would be impossible for humans to spot. These algorithms are like skilled translators, turning the brain's complex signals into understandable information. These patterns can reveal how different parts of the brain communicate with each other. They show us the intricate web of connections that make up our thoughts, emotions, and actions. They can also tell us about the brain's response to different stimuli, such as a loud noise or a virtual reality experience. By understanding these responses, we can learn more about how the brain processes information, such as sights, sounds, and even thoughts. This knowledge can help us develop new treatments for neurological disorders, improve brain-computer interfaces, and enhance our overall understanding of the human mind. In 2023, a groundbreaking study used AI to analyze brain images from over 10,000 people. This massive dataset allowed researchers to create detailed maps of brain activity. These maps are helping us to understand how the brain is organized and how it functions. The study revealed that the brain is organized into a network of interconnected regions. Each region has its own specialized function. For example, some regions are involved in processing sensory information while others are responsible for planning and decision-making. One of the most exciting applications of AI in neuroscience is its ability to predict brain activity. By analyzing past brain activity data, AI algorithms can learn to predict how the brain will respond to future stimuli. In some cases, these predictions can be made with over 90% accuracy. This predictive power has incredible potential for diagnosing and treating brain disorders. For example, AI could be used to predict which patients are at risk of developing Alzheimer's disease. It could also be used to develop personalized treatments for patients with depression or anxiety. Section 5. Mapping the brain's landscape. The 2023 study identified over 150 distinct brain regions. This groundbreaking research has provided us with a detailed map of the brain, much like a geographical map of the world. Each of these regions plays a crucial role in our daily lives, influencing everything from our basic bodily functions to our most complex thoughts and emotions. These regions are like the continents and countries on a map of the brain. Just as each country has its own culture, language, and customs, each brain region has its own unique set of characteristics and functions. This analogy helps us understand the complexity and diversity of the brain's landscape. Each region has its own unique set of characteristics and functions. For instance, some regions are specialized for processing sensory information, while others are involved in motor control or cognitive functions. This specialization allows the brain to efficiently manage a wide range of tasks and activities. Understanding these regions is crucial to understanding how the brain works. By mapping these areas, scientists can gain insights into how different parts of the brain interact and communicate with each other. This knowledge is essential for developing new treatments for neurological disorders and improving mental health. Some regions are involved in basic functions, such as breathing and heart rate. These areas are vital for our survival and are often located in the more primitive parts of the brain. They ensure that our bodies function properly without conscious effort. Others are responsible for more complex functions, such as language, memory, and emotion. These regions are typically found in the more evolved parts of the brain and are crucial for our ability to communicate, remember past experiences, and feel a wide range of emotions. By studying these regions, we can learn more about how the brain controls our thoughts, feelings, and actions. This research not only helps us understand the brain's structure, but also its function, leading to a deeper appreciation of the incredible complexity of the human mind. Section 6. Unlocking the secrets of brain regions. Each of the 150 brain regions plays a crucial role in our behavior and cognition. Some regions are involved in processing sensory information from our eyes, ears, and other senses. Others help us to plan our actions and make decisions. Still others are responsible for our emotions and memories. By understanding the functions of these regions, we can gain a deeper understanding of what makes us human. We can also start to develop new treatments for brain disorders that affect these regions. Section 7. AI as a diagnostic tool, Alzheimer's and beyond. AI is already being used to diagnose a variety of diseases, and brain disorders are no exception. AI algorithms can analyze brain scans and other data to identify patterns that are characteristic of diseases like Alzheimer's, Parkinson's, and even depression. Early diagnosis of these disorders is crucial for effective treatment. AI can help doctors to diagnose these disorders earlier and more accurately, leading to better outcomes for patients. Section 8. The promise of personalized mental health. Mental health disorders like depression and anxiety are often difficult to diagnose and treat. This is because these disorders can manifest differently in different people. AI has the potential to personalize mental health care by analyzing individual brain activity patterns. This could lead to more effective treatments that are tailored to the specific needs of each patient. For example, AI could be used to develop personalized therapy programs or to identify the most effective medications for individual patients. Section 9. The future of neuroscience, a partnership with AI. AI is transforming the field of neuroscience. It is helping us to understand the brain in ways that were never before possible. As AI technology continues to advance, we can expect even more groundbreaking discoveries in the years to come. The future of neuroscience is a partnership between humans and machines. By working together, we can unlock the secrets of the human brain and develop new treatments for brain disorders that affect millions of people around the world.